Okay, another expansion problem. Lots of tiny numbers and letters in this problem, right? So kind of hard to keep track of what's what. The 5 here, that's the base of this logarithm. Okay. The 3 is the index of this radical. And remember that the first thing we really want to do here is we want to write our radicals as fractional exponents. So in this case, because this entire quotient, this entire fraction is under this radical, that means everything in here is going to be raised to the 1/3 power. Okay. Now, when we start to expand this, we have an exponent for everything. Everything inside this logarithm, right, is subject to this exponent. So I'm going to move that down in front. Now, you have two choices. You can take the 1/3 and distribute to this product and down here. You can do that. Okay. What I choose to do is take this and move it down in front to make it a little simpler right off the bat. Now, here's the thing. When we do move this 1/3 in front, I usually put a bracket here, okay, to remind myself. And now I don't need the parentheses anymore, okay, because that exponent moved down. But I usually put brackets around this to remind me that now that I'm going to go about expanding all of this, the 1/3 applies to everything that happens. Okay, so this 1/3 is in front of this log, but this log is about to become multiple logs. So this 1/3 has to apply to all of those terms. Okay, so inside the brackets here, I'm just going to have this 1/3 hanging out here. Inside these brackets, I've got the log of a quotient. So I'll start by taking that quotient and writing it as a difference of logs. Okay, like so. And then again, once we break that fraction apart, I just like to work left to right. We realize here there's no variables, so this is going to have a value. You can do that now if you want, or you can do it at the end. Okay, but we still have this 1/3, and now this logarithm has a product inside, right? The log of a product becomes the sum of two logs. So we break this up. I skipped over this idea, but if you're watching this one, this is probably the last recorded example, if not the last, the penultimate. Okay. This 6 doesn't come in front of this log because this 6 only applies to the s. The only exponents that I can move in front are the exponents that apply to everything inside the log. That's why this 1/3 came down, right? But this 6 isn't not coming down in front of this log yet, right? We expand that into a sum. Now I've got an exponent in front of this, or I'm sorry, an exponent for the s here, and just the s that's inside, but that's all that's there. So now I'm going to write that 6 in front. So I've got 1/3. This 6 comes in front of this log base 5 of s. This logarithm has nothing, right? There's no power, there's no fraction, there's no product. Now, if you want, when you look here, what is log base 5 of 25? That's 2. Okay, so why not, right? At any point, you can do that if it makes it easier for you. What power do I raise 5 to get 25, right? Second power. So now I have no more expansion of logs, but I do have this 1/3 out here. So it's probably wise to distribute this to all of these logs. So this 1/3 gets multiplied by this log, gets multiplied by this log, and it gets multiplied by this 2. So what's 6 over 3, right? That's 2 log base 5 of s plus, there's nothing to multiply this in front of this log, so we just put the 1/3 there. And when I multiply 1/3 times 2, I get 2/3. Okay, so this is our final solution here.